Uggeri, and with me is Will Driscoll. Today we are presenting our ME416 Computer-Aided Thermal Systems final project. The project is to optimize a heat exchanger. The design problem we had to address was to design a heat exchanger to assist in the cooling of the computers at the High Performance Computing Center here at Michigan State. Here are the design parameters that we had to face.
In order to optimize the design, we varied the dimensions of the heat exchanger, and we also fixed the mass flow rates. And for the mass flow rate of water, we set it to the max allowable. And for the glycol, we calculated using the heat transfer rate equals m dot times Cp times the change of temperature, and we set the change of temperature about equal to that of the change of temperature of the water. And the outputs we found were the number of tubes, the heat transfer rate, the effectiveness, and the outlet pressure.
To optimize the system, we had to set some of the values at constant. We set the pitch layout as triangle pitch layout. The material we use is carbon steel, and we chose propylene glycol as our working fluid because it is safe to use with water if there is any sort of leak or anything. And we used a fixed head system for our heat exchanger.
We optimized the design in order to get the minimum dimensions of the heat exchanger while still meeting the temperature change, the velocity, and pressure change minimum.
Here is our outputs that we got for our most optimal design. I'd like to note that our heat transfer rate was greater than the 1 megawatt that was required, so we meet that requirement, and we have a low output pressure of only 7 kilopascals, and having the dimensions of a 6-meter tube by half a meter wide.
We used MathWorks program with the heat exchanger to calculate the cost, and the estimated cost is around $12,416.
In conclusion, we had a fixed head shell and tube design of just slightly over $12,000. The working fluid we chose to use is propylene glycol because it's safe to use with water, and with a triangle pitch layout made of carbon steel, length 6 meters long, with a width of half a meter, and there was 190 3¼ inch tubes. And a Sheco Southern Heat Exchangers is a supplier that custom makes heat exchangers. Thank you, and go green.